Welcome to all in the next lecture of elementary combinatorics, that is on combinations. So, in the last lecture, we studied about the permutations. So, what is the difference between the permutations and the combinations? In permutations, order matter means we select the objects by ordering, and in combinations, order doesn't matter. So, what is the combination? On many occasions was we are not interested in arranging, but only in selecting our objects from total n objects. So a combination is a selection of some or all of a number of different objects where the order of selection is immaterial, means the order doesn't matter in the combinations. So if here we calculate the number of selections. So total number of ways of selecting r objects total from the total n objects, that is ncr. So by combination we can represent it by ncr, n total number of objects, and r objects we have to select from the n objects, that is ncr. And what is the value of ncr? That is n factorial upon r factorial multiply n minus r factorial. And what was the permutation? In permutation, npr, that is n factorial upon n minus r factorial only. So in combination, order doesn't matter. We need to select the objects, right? So if we select the objects, that is combination. If we uh, select the ways of doing the selecting the objects, so that is the permutation. So some points are here. If suppose we select n objects out of n objects, so that's value is 1, means ncn, that is equal to 1. You can see here, if you put n in place of r, so it become n factorial upon n factorial and n minus n 0 factorial. And what was the value of 0 factorial? 1. So it become 1. Clear? Now next one is ncr is equal to ncn minus r. What does it mean? If we select the r objects out of n objects, so that is ncr, and this is equivalent to if we select the n minus r, means the r objects remaining of the objects, that is n minus r, from the r n objects, so that is equivalent to ncr. So ncr is equal to ncn minus r, both values are equal. If we select, suppose no one objects we select out of the n objects, that is ncr, its value is always 1. Next, now we can form the relation between permutation and the combination. How? Let's see here. The number of ways of choosing an ordered set of r objects out of n. R objects, we choose the R objects out of n. This is equal to the number of ways of choosing an unordered set of R objects out of n times the number of ways of arranging R objects in order. What does it mean? It means says that NPR is equal to NCR multiply R factorial. Why NCR? Because we use here the unordered set in which we select the r objects in unordered set of total n objects, so that is ncr. If we multiply this ncr with r factorial, arranging the r objects, so that is r the equivalent to npr. You can also see that what's the formula of ncr? N factorial upon r factorial and minus r factorial. And what's the formula of NPR? N factorial upon n minus r factorial. So only the difference is r factorial. So if we multiply the um, r factorial by ncr in ncr, so that will give the npr permutation. So we can see that use permutations if a problem calls for the number of arrangements. So if we have the number of arrangements of the things and different orders are to be counted, so if order matter in our, means we need to calculate the arrangement of objects, so we use the permutation. And we use the combination if we select the objects out total, from the total objects we need to select the objects and order doesn't matter, so there we use the combinations. Clear? Okay, so now we take the examples, and I think after these examples you can understand where we use the permutations and where we use the combinations. So here we take these two examples, and through these two examples we can see that where we have to use permutation and where we use the combinations. So what is our first example? First says that a teacher wants to randomly choose 5 people from the class of 30 to help out at the open day BBQ. In how many ways can this be done? So in this question we teacher want to choose 5 people out of 30. So what we use here, 5 peoples out of 30, right? So here I think order doesn't matter, because here it's not says that which students or which pupil teacher choose out of 30. Only randomly he says that that out of 30 the teacher choose 5 people. They may be anyone, not specifically is given that uh, that which 5 people teacher wants to choose, first, second, or they says the name like Aman, uh, Rohit, like that. So anyone, any 5 people here can be choose out of 30. So what we use here to find the number of ways, here we use the combinations, right? Clear? Because here the order doesn't matter, so we use the combinations. So it means the number of ways is 30c5. Clear? Because here order doesn't matter, means it doesn't mention that which 4 5 people teacher choose out of 30, so we use the combinations 30c5. And you calculate this, because here I directly you show that 30c5 means 30 factorial upon 5 factorial, and 30 minus 5 25 factorial. 25 factorial is cancelled out from the 25 factorial, so remaining we have these numbers. So after this we calculate, so we will get these 142,506 ways are there to select the 5 people out of the 31. Clear? Now next one it says that a teacher wants to award prizes for first, second, third, fourth and fifth in the class of 30. So in how many ways can the prizes be awarded? So what we use here, actually here also we have the teacher wants to award the 5 persons out of the 30, but here specifically which students teacher awarded out of 30? Which student will get the first position, that receive the price, that is on the second position, that is on the third position. So here positions are mentioned, means which student get the first, second, third, fourth and fifth position, so those students out of 30 get the prize. So here we use to find the number of ways to get the prizes, we use the permutation. So permutation 30p5, right? So we calculate our 30p5, 30 factorial upon 30 minus 5 25 factorial, 25 factorial is cancel out the 25 factorial, so remaining we have these numbers. So when we multiply this, so we will get is this 1700 720. These number of ways we can choose, so whose students get the prize, right? So see what's the difference between these numbers. Clear? So now clear where we use the combinations and where we use the permutations. So where does order doesn't matter, so you use the combinations, and where the order is matter, arrangements are matter, so where we use the permutations. Clear? Okay, so now let's take another example of the combinations. A student must select six subjects. In how many ways can they do that if there are 13 subjects and one is compulsory? So, what we use here? Here says that students select six subjects out of 13 subjects, right? So, here is not given that which subjects he choose. He can choose any subjects out of 13, any six subjects he can choose. Means here it is not mentioned that he choose the maths or the computer science or any other subjects. It's not specifically is given that which subjects he need to choose, right? So he choose any six subjects out of 13, so we use here the combinations. Now one thing is given that here one subjects out of 13 subjects, one subject is compulsory, right? So the students it select the six subjects in which one subject is compulsory. So it means that how many ways that we choose the subject, because one is compulsory. So only now our work is that we have to choose the five subjects out of 12 subjects, because one subject is compulsory, so we have to exclude that, right? Means that is compulsory. So only our work to do that, need to choose the five subjects out of the 12 subjects. So that is 12c5, right? Now you can solve this by 12c5. 12 factorial upon 5 factorial, multiply 12 minus 5, 7 factorial. So when you expand this, 7 factorials cancel out, so remaining you have these numbers, and after calculating you will get the 792 ways are there in which the student can select six subjects out of the 13 subjects here. Okay, so now the next example, in a lottery you select six numbers out of 40. How many ways are there to do this? So how many ways can you select six numbers out of 40? So here is also that no specifically numbers are given that you have to choose that only that six numbers out of the 40. Any number here it says there that any number you can choose six numbers out of 40. So here we use the combinations. So what is the number of ways? 60, 40 total, 40 out of 6 we have to choose out of 46 numbers, so that is 40c6. So you can solve this 40c6, it means that 40 factorial upon 6 factorial and 40 minus 6. So that is you have the here you can solve this, and after calculating you will get these are the number of ways to select the numbers. Now another example, you want to choose a committee of 5 people from 7 men and 8 women. How many ways can this be done? And second one is, how many ways can this be done if you want a majority of women on the committee? So here again we have to select the 5 people for the committee from the 7 men and 8 women, right? Not specifically is given that which man we need to choose for the committee, and which women's we need to find the to make the committee. Any man or any women out of 8 or any man out of 7 we can choose for to make the committee of 5 people. So we use here the combination r. Now what is the first case? In first case it says that how many ways can this be done? Total No specific, no condition is here given that how many men should be there in our five people committee and how many women should be there in our five people committee. They may be anything, man or women, doesn't matter here. So the total number of ways to choose the five members out of this total, how many out of how many members we have to select five people? 7 plus 8, that is 15. So out of 15 we have to choose only 5 people. So that is the 15C5 ways to do this. So you can solve this 15C5. So it's your task that you solve this and calculate the number of ways. I just only you represented that how and how we can use the combinations here, right? So in the second part, he says that how many ways can this be done if you want a majority of women on the committee? Majority of women. Majority of women means that out of five people, we have the majority of women. So what are the cases you have? It making the first case is if we have out of five people of committee, we have three women and two men, means total we have to make the five people committee, but here condition is given that majority of women, so women is always should be greater than the men. So we have here the three cases. First one is that in our committee of five people, three women and two men, or five women and one man, or another case is all are women, all five are women, right? So what are the arrangements, means what are the ways of selecting these? That is, if we choose three women out of eight women, so that is 8C3. If we choose two men out of seven men, that is 7C2. So here is and, so we use the multiply, means now our task is complete. We select the five persons, but this is the one way to select the five person, and the other way is to select the five persons for the committee, that is four women. So we choose four women out of eight, that is 8C4. We choose the one man out of seven men, so that is 7C1. So we multiply this. Next case is five women, means we choose only women. So out of eight women, we need to choose five. So that is the 58C5. Now we add these. Why we add? Because we use here, because our task is complete here up to here in this step that we choose the five persons, but we can choose our these five committee members like this or this or this. So we add these, all these. Clear? So here we use the product and your sum rule. So you also have to mind that where we use the product rule and where we use the sum rule. So if we have the and, so we use the multiplication, means the product rule. If we have the or, so we use the sum rule. Clear? So these ways are there. So your task is that you solve this and find your answer. Clear? Now take the next example. Find the number of ways of selecting 9 balls from 6 red balls, 5 white balls, 5 blue balls. If each selection consists of 3 balls of each color. Total, how many balls we need to choose here? 9 balls. Total we need to choose 9 balls, and we have how many colors ball? We have 3 colors ball. We have red, white and blue, and says that 3 balls of each color, means 3 balls in our 9 balls. We have 3 balls of red, 3 balls of white, 3 balls of blue, right? So number of balls we have red is 6, number of white balls are 5, number of blue balls are 5. So 3 balls of each color, it means that if we choose 3 balls, red balls, and total we have 6 red balls, so the number of ways of selecting 3 red balls is 6C3, and number of ways to select the 3 white balls, so total is 5, so that is 5C3. 3 blue balls, so total is 5 blue balls, so out of 5 we choose 3, that is 5C3. Now total we need to choose 9 balls, and 3 from here, 3 from here, 3 from here. So total task is that we have to multiply it, so total we get the 9 balls. So we use here the product rule. So that is 2000 ways we have to select the 9 balls. Clear? Next example is here. A committee of 5 members is to be formed out of 6 men and 4 ladies. In how many ways can this be done? If first is case is that exactly 2 women are included, and second one is that at least 2 women are included. So here again we have this type of question that we have to make a committee of 5 members and out of 6 men and 4 women. So here is also not specifically mentioned that which man we need to choose, which women we need to choose. So at randomly we have to choose 5 members, means we can take any man or any women. So we use the combinations here. Clear? Now how many total men's we have? 6. And how many women's are? 4 here. And our first case is that we have to choose exactly 2 women's. So in our 5 member committee we have the 2 women's only. So if we have the 2 women, should be there 2 women, it means that remaining 3 members are, they must be 6. Oh sorry, they must be men, right? So 3 members out of 5 members committee are men because 2 are women. So our number of ways to select the 2 women out of 4 women, that is 4C2, and we need to select the 3 men out of 6 men, that is 6C3. So now here we choose the 2 persons, here we choose the 3 persons. Total we need to choose the 5 persons for the committee. So our task will be completed if we multiply these, because we need to choose the 5, total 5, 2 from here, 3 from here. So we multiply here and we find the number of ways to select the 5 members, that is 4C2 multiply 6C3, so it gives the 120. So here we have the 120 ways to choose the uh, 5 committee members. Now, second case is at least 2 women are included. So now, out of 5 members, here is given that at least 2 women are included. So it means that in our 5 member committee, the women are maybe 2 or 3 or 4, right? Because we have the 5 member, at least 2 member, at least 2 women's are there. So 2 or 3 or 4 women's are there in our the 5 member committee. So how many cases are arises here? So our first case is that 2 women are there and 3 men. 3 women are there and 2 men are there, and 4 women are there and 1 man are there. So these cases are in our to choose the 5 members committee, right? So here to select the 5 members committee is that 4C2 multiply 6C3 plus 4C3, uh, because here we need to choose 2 women out of 4, that is 4C2. We need to choose 3 men out of 6, so that is 6C3. So like that we choose 3 out of 4, 4C3, that is 2 out of 4, 6 men, so 6C2. And here we choose the 4 women out of 4, so that is 4C4. And here we choose 1 out of 6 men, so that is 6C1. After that we add this, so we get the selection of the 5 members out uh, of the committee. Now one more thing is here, restricted combinations. Restricted combination, it means that if you have the number of ways of choosing r objects out of n different objects, if p particular objects must be excluded, means like that any questions you have in which you have to say is that this particular of objects you must have to exclude, it must not be there in your chosen objects, right? So this type of questions you have to do It's like that. Suppose we have the objects are a1, a2 up to ap, up to an. Total we have the n objects, and we say that if the p objects means a1 to ap are to be excluded, then it means that we have to select our objects from the remaining. Now remaining objects are n minus p because these are excluded. So initially we excluded from the total n objects, so our objects is now remaining objects are n minus p. So we choose our r objects from the n minus p objects, right? So this is n minus pcr, and we also write in the form of npr is equal to this. This is this meaning n minus pr. This notation meaning is also the combination means n minus pcr. Clear? Next one is number of ways of choosing r objects out of n different objects if p particular objects must be included. Suppose you have this type of problem that some objects you have to choose in which it is given that this particular objects you have to also consider. Means it's compulsory that you have to take. Like I think last example we did this is like that. So here suppose we have the a total n objects, so that is different objects. So p particular objects, sorry, so we have the p objects here, we include it a1 to ap, we have to include it in. So total, when we calculate our the total number of ways of choosing the r objects, it means that we have to subtract, we have to select total, selecting r minus p more objects to complete the selection, right? Means we have to subtract that p objects that are included in our the total r objects, and our total objects are n minus p. So our combination is n minus p c r minus p, right? And also we can represent it like that. Clear? Now if we have the combinations of alike objects, so the number of combinations of n identical objects taking r is less than equal to n at a time is 1. It means that if suppose we need to select the n objects out of n objects, total out of n objects means ncn, that is value is 1, right? Next one is if the number of ways of selecting r objects out of n identical objects, identical, n are the identical objects, and in from n identical objects we need to find selecting the r objects. So that is the number of ways is n plus 1. So you have to remember this. And if suppose we have the objects are p plus q plus r plus s objects are there in which p are alike of one kind, q are alike of second kind, r or are alike of third kind, and s are the different objects are there, then the total number of combinations is out of p alike objects like that we have how many ways? P plus 1. Q alike objects, q plus 1. R alike objects, multiply r plus 1 and multiply s are the different, 2 raised to the power s minus 1. Minus 1, why we take here minus 1? Because some suppose our one way is that we not choose any one, right? So we not it's our thing that we not choose any objects from these, so we subtract the minus 1. So for this for the clearance we take an example. So after this it's clear that there are 4 oranges, 5 apples and 6 mangoes in a fruit basket. So in how many ways can a person select fruits from among the fruits in the basket? So we use here the alike objects because we consider here that our 4 oranges, 5 apples and 6 mangoes are alike, right? Identical means oranges are one type, apples are all 5 apples are one type, and 4 are 6 mangoes are one type. So what are the ways for 4 alike oranges? 4 plus 1, right? I told you that for n plus 1. So 0 or more oranges can be selected out of 4 identical oranges is not 4 plus 1, and 0 or more apples can be selected out of 5 identical apples, that is 5 plus 1 ways, and 0 or 6 mangoes, identical mangoes, more mangoes are selecting for the 6 identical mangoes, that is 6 plus 1 ways. So total how many ways these are? 5 multiply 6 multiply 7, total we have the 210 ways of selecting when all three types of fruits, right? Now, but one cases was that one of these selections number of each type of fruit is 0, or hence there is no selection. This must be excluded. Means there is no selection, means we not select any fruit here, right? So we have to subtract it minus 1. So that is 210 minus 1. This is equal to 209. So total we have the 209 ways to select uh, fruits from the alike of fruits. Okay. So now today's lecture is completed now. Thank you. Be happy, be healthy.